Today we are going to create a max patch where we can interpolate between two chords. In this patch, it is possible to input two starting chords. For example, a C major chord and an E flat major 7th chord, with a nice A natural added for spice. After I do this and I click this button, I can type in the interpolation amount. 0 would be the first chord, 1 would be the second chord, and anything in between would be an interpolation between chord 1 and chord 2. For example, the middle point, 0.5, or 0.1, or I can even try to do a scale of interpolated chords and go from chord A to chord B in an organic manner. 0.2, 3, and so on. 0.9 and 1. This is a fantastic opportunity to learn about how to interpolate and explore the space between two chords. It's very exciting and could be basis for a lot of cool compositions and musical creations. So let's begin. Alright, my task is deceptively simple. I want to have two chords, and then I want to interpolate between them, right? I want to choose the amount of interpolation between chord A and chord B, and then to receive, hear, and see a new chord based on these two currently imaginary chords. So I'm going to start by thinking about the objects I need to use for such a task, right? And I know I'm probably going to be using the K-slider object as an interface to input notes for my chord A, my first chord, and chord B, my second chord. Secondly, I will need to input an amount, an interpolation amount, and for this I'm going to use a floating number box, right? Because I want to use a very specific system for my interpolation amount, where 0 means chord A. I want to hear chord A. If my interpolation is at chord 0, I want to hear chord A. And if my interpolation amount is at 1, I want to hear chord B, meaning anything in between should be a nice interpolated chord between chords A and B, right? So 0.5 would mean something exactly in the middle. 0.1 would mean something that is mostly chord A, but is a bit interpolated to chord B, and so on and so on. So this is going to be a very important value for my calculation. So these are the basic objects I'm going to be using, and then I need to also figure out what are the steps I need to take to figure out, well, how and which algorithm I should implement, right? So let's think about this. What is my shopping list? What do I want to do? What do I want to achieve step by step? And step 1 would be to create or make chords A and B and save them in arrays. I'm going to explain what arrays are in just a second. And 2, I should realize that chord A and chord B might have different amounts of notes in them. Right, so I need to figure out how many notes are going to be in the interpolated chord. Right, and then my third step, I think this is going to be the most tricky step when we get there, is going to be to figure out the MIDI note values of each note in the new interpolated chord. And step 4, play and visualize the new interpolated chord, and then maybe the most important step, right, 5, well, we have to enjoy what we have created and maybe use the chord in a composition, etc. So this is our task. This is our shopping list. These are the steps we need to take in order to implement this idea. So we can start with the very first one. Let's create or make chords A and B, and let's save them in arrays. Now, arrays are a relatively new addition to Max, right? They're not as new as you would think, but there is an array object. There are a bunch of array dots, something, 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 something objects that lets you do a lot of things with these arrays. And if you have experience with text-based programming languages, you probably know what arrays are. But if you mostly know Max and not a lot of text-based programming languages, you can think of lists, right? So lists are just messages with a bunch of elements in them. And you can think of arrays as, for our intents and purposes, a fancy list. Some kind of a container in the computer's memory where we can put a certain amount of things, with each of these things having a very specific index number, and then we can manipulate our list or an array of things, or we can interpolate between them as we desire. Right, so arrays are fancy lists. And something we can do, though, that we cannot do to lists in Max as far as I know, is to give these arrays names. So I can give it use the name attribute to give this array the name chord A. Right, and I can create another array and I can say, well, the name attribute of this one is chord B. Now, this is really useful because then down the line, as I'm implementing my algorithm, I can refer to chord A as a message or as an argument to other objects, and I don't need to directly connect these array objects to these new objects, right? So giving these arrays names will make it useful to refer to these arrays without having to create a bunch of spaghetti code in my Max patch. Right now these arrays are empty, but I can later, when I put things in them, I can simply reset them by sending them the clear message, right? So clear is going to simply clear the contents of these arrays. And if I want to take a message and add it to my array, I can simply create a message that starts with append, and then whatever I want to add to my array, like append 4, append 5, append tomato, append potato, and so on. So I'm just going to make a message box called append $1. So when my case slider sends something out, it goes here, and then append, and then the MIDI note value goes into array. I can then visualize, or at least monitor, what is in this array by sending a bang message to this array, and then simply printing the results. To make things a bit more intuitive, let's change a few things about our case slider object as well. So while the patch is unlocked, I'm going to right-click the first inlet, and I'm going to choose the mode attributes. And by default, it's going to be monophonic, but if I lock the patch and click here, I can change it to polyphonic. Right, and then I can also create the objects make note. Let's give it a velocity of 100 and a duration of 1000 milliseconds, aka 1 second, and let's also use note out. Oop. There we go, to also hear what we are playing. Right, so now I can input notes. And I'm using the polyphonic mode for case slider, so I can very clearly visualize the notes I'm looking at. I'm playing those out, I'm appending it to my array, and as I've said, now if I click on this button, look at the Max console here. Array chord A is these numbers, these MIDI notes. So these are the MIDI notes that make up my chord A, my first chord. And just like the array, if I want to clear out the notes in my case slider, I can also send the message clear to it. There we go. So I can clear this out, I can clear out my array, and I can input a new chord. Again, click the button. There we go. Now my chord A is an entirely new chord. And then I just need to do the exact same thing for chord B, and I'm going to be a bit lazy, and I'm just going to simply copy and paste the thing I have already made, and I'm just going to change the name of the array to chord B. There we go. So I can again clear both, clear everything, and I can input, let's say, a nice F major 7th chord with some added notes. And for my chord B, I don't know. I can input these notes. And now I have my chord A and my chord B. Fantastic. This means that we have completed the first step. Done. We have created and made chords A and B, and we have saved them in arrays. Okay, now the second one, right? So we have to figure out how many notes are going to be in our interpolated chord. And to know this, I need to know how many notes are in my chord A, how many notes are in my chord B, and I need to interpolate the amount of notes in chord A and amount of notes in chord B based on my interpolation value. So here is how I normally do interpolation in Max. I simply use what is my favorite object, scale. Scale is going to take an input range and map it to an output range. Right, so I can say the input of range of my scale is 0 to 1, and the output range is, for now, 100 to 250. If I take my interpolation amounts, and I visualize the result like this, using another float box, well, 0 becomes 100, 250 becomes, 0 becomes 100, 1 becomes 250, and 0.5 becomes exactly the point in the middle. Now, my problem is this: I can't really hard code the output range because it's going to be different based on whatever the length of my chord A is and whatever the length of my chord B is. But do not worry, that's why there are so many inlets in the scale object, right? The first inlet is a number to be scaled. The second and third inlets are the input, low and high values. And the fourth and the fifth inlets are the low and high output values. This means I can do a nice trick. I can simply put 0 and 1 as my output values for now. And then I can take the length of my arrays. Length here meaning how many values are in my arrays, how many notes are there in my arrays. And I can plug it into the fourth and the fifth inlet. So when I go from 0 to 1, I am interpolating between the length of chord A and the length of chord B. So let's do this. And this is the reason we are using arrays, right? I can use the array.length object, which receives an array, and it tells you how many elements there are in that array, right? Meaning if I send a bank to my chord A array, but okay, its length is 7 and my chord B has a length of 8. Now I want to trigger these together, so I'm going to use a single bank that goes into both arrays, and I'm going to take the results and I'm going to put chord A's length in the fourth inlet of scale, and I'm going to take chord B's length and I'm going to put it in the fifth inlet of my scale object. So these 0 and 1 values, the third and fourth arguments of scale are going to be replaced by, in this case, 7 and 8. Right, I click this button, this went here, so now let's try it. 0 becomes 7, and then 1, an interpolation value of 1 becomes 8, right? So 0.5 would be 7.5, and 0.1 would be 7.1, and so on. Though maybe 7 and 8 are not spicy enough, so let's try to create a larger difference between the amount of notes between chord A and chord B. So I'm going to clear my arrays, I'm going to clear my case sliders, and for my chord A, I'm going to input a simple 7th chord. 4 notes. And for my chord B, I'm going to have something a bit larger. There we go, a beautiful chord. All right, I'm fine. Again, click on this button. My chord A has 4 notes in it and my chord B has 10 notes in it, right? So now when I get 0, chord A, I have 4. When my interpolation is 1, I have 10. When I have 0.5, I have 7. When I have 0.4, I have 6.4. So the length of my interpolated chord would ideally be 6.4, and so on and so on. Now, of course, it's pretty tricky to create a chord that is 6.4 notes long. Maybe it's possible if you interpret it in certain ways, but to keep things easy, I'm going to take the result of scale and I'm going to use the round object to round the value. All right, so now 0.4 becomes 6. 6.4 is rounded to 6. We can even visualize it like this, I believe. There we go. Oh, not 80, not 9, 0.9 becomes 9.4, gets rounded to 9, and 1 becomes 10, which is of course rounded to 10, and so on. All right, so using a system like this, we can take the length of our chords and we can use the scale object and our interpolation factor or interpolation value to figure out how many notes need to be in our interpolated chord, which is now done. Okay, now comes the hairy part, now comes the difficult part. We have to figure out the MIDI note values of each note in the new interpolated chord. Meaning this, okay, let's say I want to have an interpolation value of 0.5, which means my interpolated chord is going to have 7 notes in it. Good for it, I'm sure it's going to be a beautiful chord. But now, since I know this, I need to go one by one. The first note of this chord with 7 notes, the second note, the third, fourth, fifth, sixth, and seventh notes of this chord with 7 notes, and one by one, I need to figure out which MIDI note value that specific note is going to have. This means I need to find a corresponding note in my chord A, and I need to find a corresponding note in my chord B, and I need to interpolate between those specific notes to find out that specific interpolated note of my interpolated chord. Right? So it might be a bit difficult to wrap your head around this from just me explaining it, but I'm sure it will become more clear as I am implementing this idea. Right, so let's do something like this. I actually did a little trick, I believe, and I wrote down, let me find it, there it is. I noted down the exact algorithm we need to use to figure out what we need. Right, and what I need in this case is to find a corresponding chord A note and chord B notes, right, that I'm going to interpolate between for each note of my interpolated chord. And here I need to find the index of my chord A note, and I need to find the index of my chord B note, meaning is it the first note of chord A or is it the second note of chord B I'm looking for. So index A becomes I, which refers to the index of the note in the interpolated chord. Am I trying to find out the first note or the second note or the third note or the fourth note of my interpolated chord, times size A minus 1, the length of my chord A minus 1, divided by the new size, the new length of the length of my interpolated chord, minus 1. And index B is going to be, again, I, the position of the note in the interpolated chord, times the exact same thing, size B minus 1 divided by new size minus 1. Right, so if we implement this algorithm and we find index A and index B, then we can just simply go to our arrays and pluck out the notes we need to use and then interpolate between chord A note and chord B note to figure out which note needs to be in our interpolated chords note. All right, so how are we going to do this? Well, when I encounter these kinds of algorithms, right, these kinds of mathematical-like formulas, I prefer to go from right to left, and I prefer to figure out my variables. I prefer to do the calculations in parentheses first. So for example, well, let's do new size minus 1, and I know what my new size is, right? My new size is simply going to be this specific value, right? This is going to be the specific value here, and I can simply use minus 1 to subtract 1 from this new size. There we go. So now I have my new size minus 1. Right, and I know I will need to do this twice, or I can do it once and then they can both go to the same place, but I will need 2 instances of new size minus 1. All right, and then I need to do the same with size A and size B, right? And I already have size A and size B. Those are the lengths of my chord A and chord B. Now, to avoid spaghetti code, to avoid having like too many patch chords around, I'm going to use send and receive objects. So S size A and S size B, right? So size B is this and size A is this. And then I'm going to create the corresponding receive objects, R size A, R size B, right? And I am going to subtract 1 from these as well. Size A minus 1, size B, whoops, that's a message box, size B minus 1. Whew, there we go. So I have my size A minus 1, I have my size B minus 1, and I know I need to divide these two values, by new size minus 1. Right, so I can simply use the division objects, and then put 0 dots. Well, I actually don't need to put 0 dots. Yeah, let's not do that. So divide size A minus 1 by new size minus 1. There we go. And then I'm going to do the same. Size B minus 1 divided by new size minus 1. Okay, right, and then I need to multiply these individually, separately, by what I named here I, the index number, right? So I need to iterate I need to iterate between all nodes of my new interpolated chord. And I know this chord is going to have 7 elements then. So here's what I want to do. It's tricky to do for loops in Max. If you know what a for loop is in text-based programming languages, it lets you easily iterate in a range of numbers, iterate in an array, but that's not what I want here, or it's tricky to implement specifically a for loop in a case like this. But a similar thing I can use is an object called Uzi, which is going to send many bang messages, hence the name. For example, if I give Uzi the argument 7, and if I do print, guess what is going to happen when I send a bang to this Uzi object, right? The first outlet says watch out, because when I send a bang here, it's going to send bang, 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 bang. Bang is going to send out 7 bangs in a row from its first outlet. But more interesting is its third outlet, right? Uzi's third outlet, which will send you the current index, meaning it's going to count from 1 to 7. Right, so in order it's going to count from 1, 2, 3, 4, 5, 6, 7. And this is exactly what we are going to use as our I value, right? We are going to take the length of our interpolated chord. Instead of giving Uzi an argument, we are going to send the length of our new chord to the second inlet of Uzi, acting as an argument. Instead of 7 here, sending the value 7 to the second inlet, sets the amount of times Uzi is going to send out something. And then when again we press this button, when we send this bang message to the first inlet of Uzi, it's going to send out 1, 2, 3, 4, 5, 6, 7. Now there's only one problem. This algorithm assumes that I, the index, starts from 0. Right, it's one of those computer science things. Sometimes we start counting from 1, sometimes we start counting from 0, and this is an instance where we need to start counting from 0. So what I will do is I am going to subtract 1 from the index number coming out of Uzi. So instead of counting 1, 2, 3, 4, 5, 6, 7, since I'm going to subtract 1, it is going to count 0, 1, 2, 3, 4, 5, 6. That is essentially what I want to do. Right, and how do I want this to work? I want to trigger this entire thing the moment I set my interpolation amount, right? So I set my interpolation amount, it uses scale to interpolate between the size A and size B, my lengths of my chord A and chord B. The result is rounded, it goes into Uzi, and the moment that is done, send out a bang. Right, and if we are doing these kinds of like very specifically ordered data flow, we can use the trigger object, or as the cool kids call it, the T object. And then I can type in BI, meaning from right to left, first send out an integer that is coming into this object, and then send out a bang from your first outlets. Right, so let's see. I can do, I believe, this. So when I calculate the length of my chord, first send that value to Uzi second inlet, send it to the values right here, right, and then trigger the operation. Though if I'm doing it like this, I might be having a little problem. Oh no, I'm not having a little problem. Okay, it's all good. It's all good. I was just a bit confused about order of operations, but we are going to fix that in a second. So let's think about this. Let's think about this. I am going to do it like this. What I get from the third outlet of Uzi is going to be my I value, right? So I am going to multiply this I value, the index value, with size A minus 1. There we go, just like this, right? Size A minus 1 times I. Whoa, there it is. And I'm going to do the exact same thing for size B minus 1 before I divide it by new size minus 1. I'm doing it like this so that the order of operations is very clear, and it will cause no problems in the data flow of max. So let's see, we get I here, and we are also going to not divide by, but multiply it by size b minus 1, right? So we are here right now, and then I'm going to divide it by size b minus 1. Whew, all right. And size b minus 1 is again going to be this right here, and there it is. I'm going to make this look a bit nicer, maybe like this. All right, so hopefully, I sincerely hope that this looks clear enough. Yep, there we go. So when the I value comes in, first multiply it by size a minus 1, and I'll also multiply it by size b minus 1 and take the result and divide it by new size, or the new chord size, minus 1 for both instances. And what we are going to get is index A and index B. Whew. I wasn't lying when I said this third step is the hairy one, but we are making good progress, right? So now we're going to get index A and index B per chord. But how are we going to pull out those specific notes from the arrays? Because that's going to be the problem, right? And that is exactly why we named these arrays. Because now I can do a nice little trick. And I can create an object called array.index. An array.index is going to output the indexed element of an array object, right? The right inlet of array.index is going to get the position in an array to extract what we named index A and index B. Right? We need two of these, of course, one for the chord A node and one for the chord B node. And the first inlet of array.index expects the array from which it is going to, like pull out the information. But the cool thing is this. Instead of connecting this with the array object here, which we could do, since we named these arrays, we can simply create message boxes that says array chord B, and another box that says array chord A. And when I send this message to array.index, it will understand what I'm talking about. It will say, oh, right, there is an array named chord A. I'm going to go there and I'm going to pick up whatever value is in there based on the index number I'm receiving in my second inlet. And then it's going to output that specific value, right? Let me just create some more, there we go, real estate space in my max patch. All right, so then I can simply do this. I can take my index B and put it here, but also connect this same output to the message box. And when message boxes receive these kinds of like numbers, these messages, it just triggers its contents, right? So we are not sending a specific number. We are just triggering the message array chord B to go into array.index. And we can do the exact same thing here. And if everything is fine, if we figured this thing out, we are going to get the node of chord A and node of chord B. I need to interpolate between to figure out what that specific note is going to be in my interpolated chord. So let's try this. Let's first send out the contents of our array. Let's figure out the length, send it to our send objects, and let's say interpolate 0.5. There. So then, if my interpolation value is 0.5, between this chord and this chord, one of the notes, the last note, needs to be exactly between 66 and 77. These are MIDI note values, so my new note should be an interpolation between MIDI note 66 and MIDI note 77. So let's do that. What we want to do is to interpolate between these two values. This time they are not chord lengths, these are specific MIDI note values, but the game is the same. Scale 0, 1, 0, 1, and we are going to send chord A notes into the fourth inlet, and we are going to send the chord B note in the fifth inlet. The exact same thing that we have done up here. We are also going to send the interpolation value to the scale object. Now the problem is this. Uzi is going to do this thing multiple times, right? It's like if my interpolated chord has 7 notes, Uzi is going to send out 0, 1, 2, 3, 4, 5, 6. Or if my interpolated chord has 4 notes, Uzi is going to send out 0, 1, 2, 3, and it's going to be done multiple times. And what I want to do is I want to trigger the operation of the scale on each iteration of my Uzi, right? So each time Uzi sends out something, I want to say, okay, trigger the scale operation, trigger it again, trigger it again, trigger it again. And to implement this, to make sure that this happens, I'm going to do a little trick. I'm going to create an object called floats. And float is an object, it's like a container for a float number, right? If you send a float number to its second inlet, it doesn't send anything out, but it contains it. And if you send a bang to the first inlet, it sends out whichever number it is containing in its own memory. Right, so the trick is this. First, I'm going to send my interpolation amounts to the second inlet of float. I'm just going to store it here. I'm not going to trigger it just yet. I'm just going to store it when I start with this process. And then I'm going to take Uzi's first outlet. Remember, the first outlet is going to send a bang message per index number. So index number bang, index number bang, index number bang. So for each bang, I am going to send a bang message to the first inlet of float, which will send out whatever interpolation value it received. Right, so I hope you understand how cool this is, how cool this algorithm is. We get the index number, we calculate the MIDI notes between which we have to interpolate, and afterwards we send a bang and we trigger the interpolation, and then one by one, I'm going to use prints, one by one we are getting the notes that the notes of our interpolated chord. Whew, all right. Looks like it's a lot. We are going to hear it in a second, but let's first see if it works. Let's just try to print out our interpolated note numbers, right? So again, I'm sending out the contents of my array. I'm getting their lengths. I'm sending it to the send objects, size A and size B, and then I'm setting my interpolation, which is 0.5. All right, so I made a little mistake here, and I think this is a fantastic chance to show you how important our order of operations are in Max. Usually in Max, things go from right to left and top to bottom, right? So in my current setup, my problem is that when I set the interpolation amount, well, things go from right to left, right? And to the right is this patch chord. So this entire patch chord is processed. And after it's done being processed, then I am sending out this value, or then Max is sending out this value, and then float is set, right? So maybe you see the problem here. I'm setting the value of this float object after I am done calculating everything, right? So I'm actually calculating everything based on what my previous interpolation amount was, because that's what was loaded into float, and I am sending what should be loaded into float after everything is done, because this happens first and this happens second. But what I want is for the left one to happen first and the right one to happen second. So what I'm going to do is I'm going to use again another trigger object with the arguments I. So first the right outlet happens, right? The incoming integer, well, these should be integers, ff, floats. The incoming floats numbers are sent from right to left. The rightmost outlet is the first one and the leftmost outlet is the second one. And this way, I think I have succeeded in the right kind of interpolation. So I try this again. 0 should give me, 55, 59, 62, 66, exactly what I want. And 1 should give me, again, the right values. And if I send 1 out again, or 0 or 0.5, I'm always going to get the right kinds of values. Right, now, we are going to have another problem before we play these notes, which is the fact that because we are interpolating between two numbers, sometimes we are going to get values that are like 51.5 or 62.5, or if I have very specific interpolation amounts, we are going to get very specific interpolated chords here, or interpolated chord notes here. Now, if you're into spectral music, right, this is specifically for you. This is the point where you want to take these notes, these MIDI note values with decimal places, and find a way to play them as microtonal notes, right? If you do that, then you are going to get really cool spectral interpolation between chords. But that is not my intention here. I want to use just 12 notes on my beautiful K slider. All right, so what I'm going to do is I'm going to take these interpolated note values, which might have decimal places, and I'm once again going to, unfortunately, round them. Right, and once they are rounded, they are ready to be played, which means I can just simply plug them into my K slider to visualize how they look. I can use the make note object once again to play the incoming note. I can connect it to the note out objects, as I always tend to do. And finally, I can use the N slider, the notation display object, to also display the notes of whatever it is that is coming out of the make note object. Right, so this way I believe I can hear the note itself. So 0 would be note chord A, sounds about right. 1 would be chord B, also a beautiful chord. And if I just bring this here for now to visualize it, I am going to try 0.5. Beautiful. I'm not seeing the note in N slider, right? Because I believe I also have to right click the inlet of N slider, go to mode and choose polyphonic. 0.5, there we go. So this is exactly between chord A and chord B. So 0, 0.1, 0.2, 3, 4, beautiful. We have just interpolated between chord A and chord B, and we can really pick specific values if we want to in order to create our own interpolated chords. This I find super cool because this lets us explore the realm, the world, the space between chords. You can, in theory, create infinite chords just by using this. Just for the heck of it, let's just try another pair of chords to go between. So I'm going to clear my arrays, I'm going to clear my initial poly objects, and I am going to start with a C major chord, and I want to interpolate this into a E flat major 7th chord that I just fumbled. So let me try this again. E flat major 7th chord with some notes added in for posterity. Then I have to click on this button to get their length and set everything. And now I should be able to set the interpolation amounts. 0, 1. Again, that doesn't sound right. Maybe I didn't clear it well enough. Let's try this again. Clear the array, clear the notes, input E flat major. All right, this should work, right? So let's again try, send this out, try 1. Beautiful, that's our chord. So chord 1, chord 2, interpolation 0.1, 0.2, 0.3, 0.4, and so on. Beautiful. A beautiful chord progression, and as I've said, you can use this to explore the space between two chords. You can even take a further step and try to create some kind of vector synthesis. What if you had 4 chords and you could use an object like picked slider to kind of interpolate between those 4 chords? Here they would be represented by the corners of the picked slider object. But this is maybe for another video, or maybe it's an exercise for you, the viewer. So I just hope this has been interesting to you. I hope this has been inspiring to you. I hope you create a lot of cool things with this. And as always, thank you for watching.